what I said. Because it can. We're set for drilling. Deburring tool. Alright, by trying this plate on here, you can see that I have to go all the way to the final size, all the way through with this. Oh, I'm good. Oh yeah. Screws go through from the front, and then on the back they have the standoffs, the spacers that space the deflection yoke just the right distance. There's a wire coming through right there that when I move this piece to correct for that, it's right on top of that wire. Oh, from here. No. Needless to say, I cut the wrong damn side off. It's either right or wrong, but it's probably wrong. Oh, pretty good. Pretty good. Pretty good. Pretty good. That's pretty good. Now, okay, this fella's going to need rubber feet, which we'll probably go buy today. Leave, we can mount. camera tube is mounted in the box. This is what I was talking about earlier, about the drill chips. I don't know if you can see it in there. It's right here. Right across all the pins of the chip. It's the way it has to be. Alright, I finally obtained a good sized shielding box for the power supply, and it will go into the camera right here. Behind the camera tube. Oh, right. It has a metal lid, and I have to allow clearance for that between the lip of the box and the back wall, the small box and the big box. If I have to leave a gap, that's okay, not a problem. Okay, that's easy. Okay, and then, sorry about that. And then, to get the wires in and out of that box, I bought a ton of these. They're called Feedthrough capacitors. I believe these are 1,000 picofarads, or maybe 500 picofarads. I'm not sure. Not exactly sure. It's not important. I'm running only DC voltages through them. So all of the wires going in and out of the box will go through one of these capacitors. It's a capacitor and a pass-through to get the signal in and out. So it should keep most of the noise inside the box. I also bought more high voltage bypass capacitors, and I'm going to just literally bypass every point on the voltage divider chain. I'll tell you more about that when we look at the schematics when this thing is running. I have already drilled the little box for the standoffs of the board inside, and you can see the screws sticking through. I'm going to drill matching holes straight through the big box, and this little box will be held in by the retaining nuts on the bottom of the big box. The control pots will be mounted inside the shielded box as well, and will protrude through, and I will drill matching holes in the big box. So nothing in this circuitry will be exposed to the outside when this whole thing is completed. It will all be sealed up inside to keep all the switching noise from this high frequency switching power supply. Hopefully keep it inside this box. Before I get too much farther, I'm going to take the time to make a pictorial diagram of the box before I spend too much time putting it together and taking it apart, and putting it together and taking it apart. I now have a plan to work from. Alright, 12 holes for the 12 feed-through capacitors. The plan is to install these so that the nut, the retaining nut, goes on the outside of the box. That way I can unsolder the wires from the capacitors, remove the nuts. We can pull the board out with these still attached to the wires. Right? No guts, no glory. That was my feeble imitation of Jack from Gold Rush. basically will this go in? Yes, the answer is yes. That works quite well. That'll be okay. It's a tight fit. It is a tight fit. Put the pots in, put the board in. A lot of putting it together and taking it apart, putting it together and taking it apart. One more. Here he is. This pot is my most critical one because it's sitting at 1500 volts. So it's the most likely one to arc. The test here is to see if I can get the board out once I put the pots in. Okay, apparently.